Hey IGCSE Physics students, welcome back to the channel. This is Tanya Chu. In this video, I'm going to discuss Cambridge IGCSE Physics Paper 2, which is multiple choices questions, extended paper. The paper that I'm going to discuss in this video is paper 23. So are you ready? Grab your pen, grab your paper. Let us start with our discussion. Now, let us look at the first question. Number 1, which quantity can be measured using a ruler? You know, ruler is used to measure length, used to measure distance, short distance within 100 cm, and height within 100 cm as well. Let us look at the choices one by one. Now, A, the distance traveled by the toy train in 1 second. So it can be within 100 meter. This is true. Let us look at B, the temperature of the toy train. Temperature cannot be used, okay? Temperature cannot be measured by meter ruler. It can only be measured by thermometer. So this is wrong. C, the time taken for the toy train to travel 1 meter. That is not meter rule to measure. The time taken must be measured by stopwatch. This is also wrong. The volume of a toy train. Now, since the toy train is small, the size of the toy train is small, you can use displacement method. You can use displacement can to measure the volume of a toy train, or you might want to use measuring cylinder. So you fill in water into the measuring cylinder, and then you carefully place your toy train into the measuring cylinder, and then you take a final volume. But before that, before you put in toy train, you have to take the initial volume of the water without the toy train. So when you put in the toy train, the level of the water is going to rise up. So you take the final volume. The difference between the two volumes of water give you the volume of the toy train. So the answer is A. Number 2, a car is driven from one town to another town along a road that is not straight. Maybe like this. Okay. So maybe this is town A, this is town B. The driver of the car divides the total distance traveled by the total time. Total distance divided by total time, that is the formula of average speed. So B is the answer. Acceleration is the change in velocity, final velocity minus initial velocity per time taken. That is acceleration. Kinetic energy is your half multiplies by the mass of the car multiplies by the speed of the car. Square it. And velocity of the car is the change in displacement per time taken. So that is why the answer is B. Number 3, which quantity can be determined from the area under a speed-time graph? When a graph is being given, this is speed, this is time graph, right? Regardless of the shape of the graph, straight line, curve, never mind, not a problem. There are two information that you could obtain from the graph. One is the gradient of the graph. The other one is the area under the graph. The gradient of the speed time graph represents acceleration, and the area under the speed time graph represents the total distance. Look at the question again. Which quantity can be determined by area under the speed time graph? That is distance. B is the answer. Number 4, students are asked for a statement about the weight of an object. 3 of the statements are listed. Which statements describe the weight of the object? Let us look at the first one. The weight is the quantity of matter in the object. That is not true. It is mass. Mass is the amount of matter or the quantity of matter contained in an object. So number 1 is definitely wrong. Right, number 2, the weight is the effect of the gravitational field acting on object. Yes, that is true. And number 3, the weight is the force of attraction between the object and the earth. Yes, that is true. So D is the answer. Number 5, samples of 3 different liquids have equal masses. Their volumes of the samples are 190 cm cube, 200 cm cube, and 235 cm cube. The liquids are poured into a large measuring cylinder, and the liquids from 3 separate layers because they do not mix. They form three separate layers. They do not mix. And what are the readings on the measuring cylinder at the two boundaries between the samples? If I want to make them, if I want to make my calculation to be simpler, I would compare in terms of their densities because the volumes are different, but their masses are the same. So the densest liquid will sink and the least dense liquid will rise at the top of the surface of the measuring cylinder. Right, so I am going to assume that since they all the liquids have equal masses, so I'm going to assume their masses would be 10 gram. So I'll put this as liquid 1, this is liquid 2, and this is liquid 3. And I compare in terms of their densities. So density of the liquid 1 will be 10 gram divided by volume 1, 190. And I got 0.0 53 gram per cm cube. What about density of liquid 2, volume 2? 10 divided by 200 and I got 0.050 gram per cm cube. And the density of liquid 3, volume 3, which is 10 divided by 235 cm cube and I got 0.043 gram per cm cube. Could you see that liquid 3 is the least dense? Right. So that is why it will be floating on top of the measuring cylinder. So I'll do it one by one. Okay, so the densest would be liquid 1, 190 cm cube. And then, okay, followed by the second densest, which is 200 cm cube. Right. I want you to know that the reading in the measuring cylinder is that when this one reads 190, right, you have to add this because the volume is increasing, right? When you add another liquid onto it. So this is 390 cm cube. This reading right here is 190 cm cube. And the last liquid right here, which is 235 cm cube. So you take 390, add with 235. So your answer here would be 625 cm cube. So what are the readings between the boundaries, right? So I would say that 625 is out of our answer. So this is 390 and 190. That is why the answer is A. Number 6, a car moves along a level road. The diagram shows all the horizontal forces acting on the car. Which statement is correct? Now, I can see that there are two resistive forces. One is air resistance. The other one is a frictional force acting in the same direction. I would like to add these two first to give the total resistive force. So the total resistive force would be 800 plus 500, which is 1,300 Newton. So, okay, if I want to see whether the car is moving faster, slower, or not moving, or moving at constant speed, I have to compare in terms of their forces. I need to find the resultant force. This is the resultant force, yeah? So I need to find the resultant force acting on the car. Resultant force is the sum of all the forces that are acting on one object. So the resultant force on car, I consider two forces. But hey, don't forget, force is a vector quantity. So you have to consider positive and negative directions. Right, so forward force, I will consider it as positive direction. And backward force, which is 1,300, I'll put it as negative direction. Right, so the resultant force on the car is 2,000 plus negative 1,300, and I got 7,000 Newton forward. So this is the resultant force. Resultant force of 700 Newton. And another thing that you should bear in mind is that whenever there's a resultant force, there must be followed up by acceleration because resultant force produces acceleration. So it is forward acceleration. So the car accelerates forward. So it also means that the car is speeding up, move faster. Number 7, a car is traveling around a circular track at a constant speed as shown. In which direction is the resultant force on the car? So you want to see, I give you some tips here, very easy. If you see the word like circular track, bend, curve, right, at constant speed, just remember one thing. Yes, there is a resultant force. The resultant force is called centripetal force. Centripetal force is a resultant force that responsible, right, to keep a car in a circular track. And it has to act towards the center of the circle. B is the answer. Number 8, a railway truck of mass 8,000 kilogram moves with a velocity of 1 meter per second to the right. It collides with a railway truck of mass 12,000 kilogram moving at 12 meter per second towards the left. The two trucks become joined. You see this word join to each other when they collide and move off together. What is the velocity of the two trucks after the collision? If there are two objects involved in a collision, you can use the principle of conservation of momentum. Principle of conservation of momentum states that the total momentum before the collision must be equal to the total momentum after the collision. I'm going to draw a diagram so that you can see it clearer. So I'm going to draw it here. This is 8,000 kilogram truck, which is moving to the right 1 meter per second. And another truck, which is bigger, 12,000 kilogram, moving to the left with 2 meter per second. This is before collision. And after the collision, the two trucks join together. The bigger one and the smaller one, they join together. 8,000 kilogram and 12,000 kilogram. I look at the diagram that I drew, right? I noticed that 12,000 truck, right, is heavier, the mass is larger, and the speed is larger. So I would say that the 12,000 truck will push the 8,000 truck to the left. But don't worry with that. You can put your velocity to the right because the question did not mention. But I have to state one more thing right here is that I would assume towards left because momentum is a vector quantity. So you have to consider the direction of their velocities. Towards left as positive. Towards right as negative. Direction of the velocities towards left as positive, towards right as negative. So this is negative, this is positive, and this is positive. But if my final answer of V is in terms of negative, it also means that the two trucks are moving towards right. Now I'm going to use the principle of conservation of momentum. M1U1 plus M2U2 is equal to, since they join together, I'll add out their total masses and times with their shared velocity. Now, sub in the number 8,000 times negative 1 plus 12,000 times 2 is equal to 8,000 plus 12,000 times V. 8,000 plus 24,000. That will give me 16,000 right here is equal to 20,000 V. V is equal to 16,000 divided by 20,000. So the answer is 0.8 meter per second. And I get a positive value. That is why the two trucks are moving to the left with 0.8 meter per second. Number 9. A stone is dropped from a bridge, okay, into a Burford River. So this is a river. And there's a stone and the height of the bridge and the river is 22 meters. What is the speed of a stone when it hits the river? So if you see a height is being given and they ask you for the speed, I would prefer you to use the principle of conservation of energy. So the total initial energy is converted to the total final energy. Total initial energy of the stone, because the stone is at a certain height, the stone has gravitational potential energy, which when the stone is falling, its gravitational potential energy is converted to its kinetic energy. So gravitational potential energy, mgh, is equal to half mv squared. Can you see that? I don't need the mass of the stone. So G is 9.8, H is 22, equal to half V squared. Just make V as the subject, 9.8 times 22 times 2, and square root the answer. And I got 20.8 meter per second, which I rounded off to 21 meter per second. That's the answer. Number 10, which row describes the particle structure of a gas? So when you see the word vibrating, this is definitely for solid. Only solid can vibrate. So you can eliminate A and C. Let us look at gas. Gas, the particles are moving in random direction. And the distance between the particles are far apart from each other because the intermolecular forces between the particles are smallest. That is why they are free to move about in their own directions. Number 11, the particles of a gas in a container of fixed volume. Fixed volume, this is particles, fixed volume. These are all the particles of the gas. And then, oh, gain energy. Can you see? Gain energy in kinetic storm. So that also means that these particles, gas particles, are gaining kinetic energy. Which effect does this have on the gas? Gain kinetic energy, still remember, kinetic energy is related to temperature. When the kinetic energy is gained, temperature must be increasing. So when the temperature of the gas is increasing, so the gas move faster. The gas particles move faster. When they move faster, they will collide with themselves and wall of container more frequent. So when they collide more frequent, they will rebound back at the same speed, and then they will exert larger force on the surface area, inner surface area of the container. So force increases, the pressure is equal to force over area. When the force increases, the pressure of the gas will have to increase. A is the answer. Number 12, gas particles exert a pressure when they collide with the wall of the container. Which statement about the gas particles is correct? They experience a change in force, which result pressure. Pressure is equal to force over area. So this A is wrong. B, they experience a change in force, which result pressure equals to momentum over area. No, it is equal to force over area. C, they experience a change in momentum, which is true, which result a pressure is equal to force times area. No, pressure is equal to force over area. That is why D is the answer. Force is defined as the change in momentum per time taken. Right? Therefore, these gas particles will experience a change in momentum because they collide with the wall of the inner wall of the container and they rebound back. There is a change in momentum. Number 13, a solid changes into a liquid. Which term describe this change takes place? Right? In state, solid changes to liquid, that is called melting. Boiling is when liquid changes to gas. Condensation is when the gas changes to liquid. Freezing is when the liquid changes to solid. So D is the answer. Number 14, the diagram shows some of the apparatus used to determine the specific heat capacity of the metal block. Which additional pieces of apparatus are required to find the specific heat capacity? Before that, I need to write the equation of the specific heat capacity. E is equal to mc delta change in temperature. The C represents the specific heat capacity, M, change in temperature. I need a thermometer, yes. And then this is a power supply with the potential difference, EMF, voltage. And then this is a current with I. That means the thermal energy or E is not being given. But don't worry, still remember, E is equal to power times time. Energy is equal to power times time. So we can replace this power times time over M times the change in temperature. I need to measure, because thermometer is given, that is why I can measure the change in temperature. But I need the mass. I need the mass of the metal block. I need the time because I can find the power. How to find the power? Power is equal to IV. So not a problem. I can take the reading from the power supply and I can take the reading from the ammeter. So I need the time. I need the time. Oh, I need the voltmeter because this is the EMF given. This is EMF. I need a voltmeter to measure the potential difference across the metal. Right, so that is why I need a voltmeter. I need a balance. A is the answer. Because only ammeter is given, but voltmeter, I need to take the reading from the voltmeter to determine that V. So A is the answer. Number 15, four different surfaces are at the same high temperature. Which surface emits thermal radiation at the slowest rate? Slowest rate, surface area must be the smallest. Texture must be shiny. Why? Because shiny surfaces reflect most of the heat. They do not absorb the heat, so they do not have heat to be radiated. They do not have that much of the heat to be radiated. And the color of the surface cannot be black, but has to be white. Right? Because black color is the best absorber of heat and the best reflector, radiation of heat. So smaller surface area and shiny and white. C is the answer. Number 16, an object has a constant temperature. Which statement is correct? There is no energy transfer to or from the object. No energy there is, okay, or there are energy transfer and away from the object. It is just that when the temperature is constant, it means that no resultant or net energy. I need the word net energy transfer between the object and its surrounding. B, the rate at which the object receives energy is the same as the rate at which it transfers the energy away. So I receive that much, I transfer away that much. So the net or the resultant energy is equal to 0. Yes, B is the answer. Cannot be smaller, cannot be greater because the temperature is constant. Number 17. Which role correctly describes light wave? Light wave is a transverse wave and the direction of the vibration is perpendicular to the direction of the wave travel. D is the answer. Number 18, a narrow beam of light consists of two waves at different wavelengths. The beam of light hits a sharp edge. You see the word edge? That means it's like a barrier. So which effect will be seen beyond the sharp edge? The barrier. This phenomenon is called diffraction, spreading of wave. Right. A, both waves continue along the same straight line. No, it cannot continue because it hit the sharp edge. Both waves bend sharply and continue along a new straight line. No, diffraction depends on wavelength. Since the wavelengths are different, so it cannot travel in the new straight line. Now, see the wave of longer wavelength bends around and the sharp edge more than the wave of shorter wavelength. This is definitely true because the length of the wave is longer, it can bend even more. Right? C is the answer. Number 19. An object is placed. Okay, I draw a plane mirror for you. This is a plane mirror. Okay, this is the back of the mirror. This is the front, okay? Where the object is facing is called the front of the mirror. So this is an object which is 30 cm in front of the plane mirror. What about the image? Oh, image must be exactly from the plane mirror to the image. It has to be 30 cm as well. Right. A, the image is the same size, definitely has to be same size because this is plain mirror, a flat mirror. Right. As the object and 30 cm from the object. No. Object and the image is 60 cm. Object and the mirror 30 cm. Image and the mirror is also 30 cm. So this is wrong. B is the answer. Number 20, which statement about total internal reflection at a glass air boundary is correct? Now, A, the angle of incident inside the glass must be equal to the critical angle. No, if the angle of incident in the glass is equal to the critical angle, the, the wave would be refracted at 90 degrees at the surface of the glass. So this is wrong. It is not total internal reflection. B, the angle of incident inside the glass must be less, cannot be lesser. So there are two conditions to be fulfilled in order for the total internal reflection to occur. The wave must be traveling from the denser medium, in this case is from glass to air. Second, the angle of incident must be larger than the critical angle. If lesser than the critical angle, some of the waves will be refracted. Some of the waves will be reflected. C, the critical angle is proportional to the refractive index of the glass and is equal to 1 over sine C. It is not directly proportional. It is reciprocal to the sine critical angle. D, the speed of light in glass must be less than the speed of light in air. This is definitely true. The speed of light in air and in vacuum is the same, 3 times 10 to the power 8. The speed of light in any other medium will be lesser than that. D is the answer. Number 21, what is the speed of radio wave in vacuum and what is the speed of gamma ray in vacuum? Radio wave and gamma rays are both electromagnetic waves that travel with the speed of light in vacuum. C is the answer. Number 22, a student makes a sound in front of a large wall. She hears an echo. Echo means reflection of the sound wave. At time t after making the sound, the speed of a sound in air is v, which expression is used to calculate the distance between the student and the wall. You see the word echo or reflection of the sound wave. You have to modify your equation to v is equal to 2 times the distance over t. Do you know why? Let me draw it. This is a large wall. And this student make a sound. Okay, make a sound. So the sound travel with a certain distance. I try to draw the notes for the music actually, right? So this is a distant travel, and in order for the student to listen back to his own reflection, the sound needs to be traveled back to his ear. So that is why the total distance must be 2 times the distance to and fro, right? That is why I put 2d. So used to calculate the distance, you make the distance as the subject. Distance is equal to speed times time divided by 2. So C is the answer. Number 23, what is a compression? Compression is the term we use to describe longitudinal wave, not transverse wave. A point, a longitudinal wave, where the particles of the medium are closer together, compressed, they are closer. When they are far apart, we call this as rarefaction. Now, 24, which rho describes the magnetic field around a weak magnet? Weak magnet, the spacing of the field lines must be far apart. And the magnetic field travels from North Pole to South Pole. B is the answer. Number 25, a 0.6 meter length of resistant wire with a diameter of 0.25 mm has a resistance of 6 ohm. This is a relationship between resistance and other physical quantity. Do you should remember? Resistance is directly proportional to length. Resistance is inversely proportional to cross-section area of a wire. But wire, this is a wire. The cross-section of the wire is actually a circle. So you want to find the cross-section, it is equal to pi r squared. But there is no apparatus in our physics lab that can be used to measure the radius of the circle. So we only have the micrometer, and micrometer can be used to measure the diameter. But no worries, because there's a relationship between radius and diameter. Radius is equal to diameter over 2. So that is why your cross-section area of the wire is pi r square. I replace with d over 2 square. And finally, I get pi d squared over 4. So I combine all these equations together. I put r is equal to a constant. I just put a k. Length over pi d squared over 4. And sub in the values that I have. The length, okay, the resistance is 6. Constant is just a constant. Length is 0.6 meter. Pi, okay, this is 0.25. Millimeter, I just put it as millimeter. Okay, replace it. Or you can put it as, I convert it to meter. Divide 1000 actually. Right, you square it, divided by 4. I put this as equation 1. Second piece of the resistant wire, same material, so the constant must be the same. So the resistance is also 6, constant. And the length of the second one, I just put L over pi. Diameter is different, 0.5 times 10 to the power negative 3. That means divided by 1000. You square it, divided by 4. Second equation. Since both of the resistances of the wires are the same, so I will say equation 1 is equal to equation 2. K 0.6 over pi 0.25 times 10 to the power negative 3 square divided by 4 is equal to K L. I want to find L. Pi 0.5 times 10 to the power negative 3, you square it over 4. What shall I do here? I just cancel the K. I just cancel pi over 4. And then I do my cross multiplication. I times out, so this is 0.6 times 0.5. Okay, times 10 to the power negative 3, you square it, is equal to 0.25 times 10 to the power negative 3, but you have to square it times with the length. So let me do my calculation. This is 0.5 times 10 to the power negative 3, and I have to square it times 0.6, and I got 1.5 times 10 to the power negative 7 is equal to 0.25. And 10 to the power negative 3, you square it. Here I got 6.25 times 10 to the power negative 8. L. So L is equal to 1.5 times 10 to the power negative 7 divided by 6.25 times 10 to the power negative 8. Let me do it. 1.5 times 10 to the power negative 7 divided by 6.25. And I got exactly 2.4 meter. D is the answer. Number 26. A circuit contains a cell with an electromotive force, 2 volt. Current in the circuit is 2 ampere. How much energy is transferred by the cell in 2 minutes? I am going to use this E equals to VIT. But bear in mind, look at the 4 choices here. All the 4 choices, the energies given are in joules. So that is why you have to make sure that the time is in second. That is one of the careless mistakes made by most of the students. So you have to be extra careful. V is equal to 2, I is 2, and the time I have to change it to second. Remember, 2 minutes, you want to change it to second, you just times 60, and I got 480 joules. D is the answer. Number 27. What is the electromotive force of a cell? The charge that passes through the cell per unit time. Charge per unit time. This is current, nothing to do with electromotive force. B, the energy supply per unit charge as the charge passes through the cell. Sounds correct to me. C, the total charge flowing through the cell. That is still the charge. Total energy stored in the cell. That is the energy, electrical energy, or the chemical, electrical energy. So B is the answer. Number 28, four lamps and four switches are connected to a power supply as shown. When all the switches are closed, all the lamps are lit. When one of the switches is then open, only one lamp goes out. Which lamp is open? So A and B must be closed. This is the main circuit. And I want only one lamp goes out. Oh, this has to be C. C is connected to only one lamp, the switch of C. So the answer is C. Now, number 29. In the mains electric wires are the fuse and the switch placed. Fuse must be placed in live wire because it is used in protecting the electrical appliances. Switch must also be placed in a live wire where the current is flowing. B is the answer. Number 30. This is a little bit tricky question. Number 30. The diagram shows a wire moving downwards in a magnetic field between two magnetic poles. There is an induced current. Okay, this one you have to be extra careful in the wire because of the movement of the wire. The induced current produces a force on the wire. Double doing it. In which direction is this force? First of all, don't worry, we do it one by one. So the wire is moving downwards. You look at the diagram, right? Exactly like what they show you. The wire is moving downwards. There is nothing. There is no electricity. There is no power supply. There is no cell. There is no battery connected to the wire. So this is wire, okay, induce the current inside the wire due to the movement of the wire, right? So where is the direction of the induced current? First step, we need to determine the direction of the induced current. But how are we going to determine? We use our Fleming's right hand rule. This is my right hand, right? This is my right hand. Fleming's right hand rule, right? Now, the movement of the wire. So I just align this is my right hand, right? North and south, okay? You point your first finger towards right. Use your right hand, points your first finger towards right. And then the movement of the wire is downwards. That means the force applied towards the wire is downwards. You move downwards like that. Could you see that? Oh, okay, like this. Could you see that? Now, my second finger is pointing at myself. That is where the induced current is flowing. This is the direction of the flow of the induced current. And due to the induced current flow in the wire, remember, wire has its own magnetic field. The magnetic field of the of the current, right, of the wire interact with the magnetic field of the magnet. So the interaction between the two magnetic fields gives rise to the magnetic force acting back on the wire. So you have to assume the second situation, there is a current flowing in the wire due to the induced current, right? Due to the movement of the wire. So due to the induced current, as long as there is a current flowing in a conductor, the conductor has magnetic field around it. So the magnetic field of the wire interact with the magnetic field of the magnets there. Due to the interaction between the two magnetic fields, there is a force acting on the wire. So to determine the force on the wire, you have to use your Fleming's left hand rule. So Fleming's left hand rule, yeah, this is my left hand, north to south. Right, I have the direction of the induced current which is flowing towards me, out from the screen, going towards me. You see my thumb? My thumb is pointing upwards. Right, so the magnetic force acting on this wire is in the upwards direction, is in direction A. So still remember when you see the induced current, first of all, right, there is an induced current, but the question did not give you the direction of the induced current. So you have to determine the induced current, direction of the induced current. How do you determine? Using your Fleming's right hand rule first to determine the direction of the induced current. So once the direction of the induced current, okay, this is, I better write it for you. Okay, this is the direction of Induced current. Since we have the direction of the induced current, you want to determine the force, you use your Fleming's left hand rule. That's it. So the answer is A. Number 31. When the generator shown rotates, there is an AC electromotive force across the resistor between points P and Q. Diagram 1 shows the position of the coil at time t equals to 0. The coil rotates clockwise. At time t1, the coil position is horizontal as shown in diagram 2. The graph shows the output EMF between points P and Q plotted against time. Which point shows the EMF at time t1? This is t1, this is t equal to 0. This is t equal to t1. Could you see that this is AC generator? Right now, when the coil is in this position, because between between the two sides of the coil, there's nothing, it's just air. There is no coil that cuts the magnetic field of the magnet. So that is why EMF induced is equal to 0. This is time equal to 0. So when the coil is at the horizontal direction, maximum cutting of magnetic field occur, which induces the maximum EMF. That is why the answer is A. T is equal to T1. Answer is A. Number 32. What is the purpose of split ring commutator in an electric motor? A, to ensure the magnetic field in the motor changes direction. I don't want the magnetic field to change the direction. Right. B, to ensure the magnetic field in the motor stays the same direction. No, this is not the function of the split ring commutator. Split ring commutator is to reverse the direction of the current flow in the coil in order for the electric motor to turn in one direction only. C, to ensure that the turning effect on the motor changes direction every half rotation, not changing direction. Make sure that it turn in the same direction. D, to ensure that the turning effect on the motor stays in the same direction all the time. Yes, correct. Number 33. A beta particle has less mass than an alpha particle, but the speed of the beta particle emitted during a radioactive decay is approximately 20 times greater than the speed of the alpha particle. Which statement correctly compares properties of these two particles? A. Alpha particles are less penetrating. Yes, this is true because they have less kinetic energy, not because they have less kinetic energy. It is because they have larger mass. They're bigger, so they can penetrate a lot of stuff, right? They can be stopped by a few sheets of paper. So this is not true. Not because they have less kinetic energy, because they have bigger mass. Alpha particle is not penetrating, less penetrating as compared to beta. C. Alpha particles are less ionizing. No, alpha particle has the best ionizing power. So D, alpha particles are more ionizing because they have more kinetic energy than beta particles and they are strongly charged. So that is why they can pull out the electrons, valence electrons from the valence shell in a normal air particle. So D is the answer. Number 34, which observation provides evidence for the nuclear atom? So nuclear atom, attraction of opposite charges, not so correct. Emission of gamma rays during the decay of radioactive nuclide, no. And scattering of the alpha particles by a thin metal foil, that is true. That is how due to the alpha particle scattering experiment, we have our model of atom. Number 35. Which effect on living things is not caused by ionizing radiation? Cancer, yes. Cell death, yes. Infection, this is caused by virus. This is not true. Mutation, yes. C is the answer. Number 36, isotope X is radioactive. Which statement about X must be correct? So it is radioactive and then because it is unstable. A is the answer. Whether it will emit alpha particles, beta particles, or gamma radiation depending on that isotope size. Number 37. An experiment is done to measure the radiation from a radioactive source. The source has a half-life of 10 minutes. The source is placed close to a detector that is connected to a counter as shown. Average background count rate is 20 counts per minute. At the start of the experiment, the count rate recorded by the counter is 1000 counts per minute. What is the count rate 10 minutes later? How do you do it? First of all, the detector is not selective. As long as there are background radiation, the detector will still detect it and give rise to the reading on its counter. So if you want to find because this is a half-life of the radioactive source. So since the background radiation is counted, you need to find the corrected initial count rate. Corrected initial count rate is the count rate due to this radioactive source only. So it is the detector reading minus the background radiation. So you get 980 counts per minute. 980 counts per minute, that is the initial count rate due to radioactive source. So I draw a table like this. Initially is 980. This is when time equal to 0. And at half-life, this is the initial count rate must be decreased by half. So it is, you just divide 2. This is 490. This occur at 1 half-life, which is 10 minutes. Right. Now, what is the count rate 10 minutes later? The count rate is the count rate detected by detector. So count rate, okay, by detector, like what I told you, detector is not selective. You need to take the count rate of the radioactive source after 10 minutes plus back the background radiation. So you get 510 counts per minute. C is the answer. Number 38. In which direction does the sun appear to move every day when viewed from Earth? Earth, you see the sun move from east to west. Number 39. A distant galaxy is moving away from the Milky Way at 440,000 meter per second, okay? What is the approximate distance between the Milky Way and this distant galaxy? So you have to know that speed of the galaxy that's moving away is directly proportional to the distance between the galaxy and the Earth. So to get rid of this proportionality symbol, I put Hubble constant D. So the speed is given 440,000, and Hubble constant is 2.2 times 10 to the power negative 18 per second times the distance. So the distance will be 440,000 divided by 2.2 times 10 to the power negative 18. And the distance that I got was 2 times 10 to the power of 24 meter. C is the answer. And number 30, the orbit of Mercury is closer to the sun than the orbit of the Earth is to the sun. How do the values of the gravitational field strength of the sun near Mercury and the orbital speed of the Mercury compares to those values for the Earth? Right, so the gravitational field strength of the sun near the Mercury will be greater because Mercury is closer to the sun. Right. And then the orbital speed of the Mercury, because the orbit is small and the gravitational field strength is stronger, so the gravitational force acting on the Mercury is larger. That is why Mercury has a faster orbital speed. A is the answer. So that is the end of our discussion. Thank you very much for watching. See you in my next video. Bye.